Welcome back to the channel. Today we're diving into the freshly released Linux Kernel 6.15, which Linus Torvalds officially merged after a calm final week and called it nothing particularly scary. As always, this update brings a broad set of improvements and a few changes that have sparked debate among kernel developers. In this video, we'll walk through the most noteworthy additions, from new graphics driver support and core subsystems to file system optimizations and hardware enablement. By the end, you'll understand what's changed under the hood and why it matters for your Linux experience. Graphics and driver updates. Let's start with graphics. Linux 6.15 introduces a foundational stub for a brand new open-source NVIDIA driver called Nova. If you recall, Nouveau has been the community's go-to NVIDIA driver for years. Nova is intended as its successor for modern GPUs built on NVIDIA's GSP architecture. At the moment, it's just the early groundwork. No display-side code yet, but the exciting twist is that the driver is being written in Rust. While it won't affect your desktop immediately, pay attention to Nova as it evolves. NVIDIA support on Linux has had its ups and downs, so a fresh Rust-based driver could eventually reshape things. Meanwhile, Intel's Xe graphics code continues to mature. In 6.15, the Xe driver gains shared virtual memory, SVM support, which allows the CPU and GPU to share memory pages more efficiently. There's also a new device wedged event, so if your ARC GPU locks up, user space software can be notified immediately. Plus, Intel added hooks for reading GPU and RAM temperatures via the HWMON interface on ARC hardware. These under-the-hood tweaks help with performance monitoring and stability. Core subsystems, FWCTL, and I/O _Uring. One of the most talked about additions in 6.15 is the new firmware control framework called FWTL. This subsystem lets user space make defined remote procedure calls, RPCs, to firmware on devices. Initially, it supports 140 devices, Mellanox MLX5 network adapters, and AMD/Pensando distributed services cards. In essence, FWCTL is meant to standardize how firmware is configured, updated, or debugged from user space, all through a secure interface. Proponents see this as a step towards safer, more uniform firmware management, but some developers have criticized it for not following traditional kernel development conventions and argue that existing interfaces might have sufficed. Either way, FWCTL